That's the menu.
No, that's a bit old.
Yeah, it's only open once. At any rate, I'll bring up the file that we just did. And I said I want to do it at point 2. There's point 2, point 2.
You see how it's over smooth if you don't
Yeah.
put it.
Point 2.
Well, you can just do that manually anyway.
Yes.
It takes 2 seconds to do.
No, it's working automatically too. Just something was
And then I
wrong.
want to set up the type of filtering that I have here. In this case, it's quintic spline. I want to go back to that. So change it. Point 2. Point 2. And we'll spend a little time on filtering later, so I can teach you how to do it by hand if we need to. And under options, we choose the algorithm by default, and then we designate point 2. Point 2. Okay. And now I can advance 1 frame at a time, like that. Or I can go back and say go, and it would go through all of them to finish it. And I'm happy with that. Now I'll go to the display. Display. Display, of course, is where you answer your questions that you have about that performance. Okay. If I want to bring up the stick figure, I hit stick figure. If I want to see the video, I bring up this, camera 1. Okay. If I want to see the video and the stick figure together, do that. Make this a little smaller. And then if I say play, it gives me everything synchronized together.
So this is basically just setting up your report.
Right. And then the next thing is I want to ask a question about that performance. So I go to 3D and I put the file in. And now I go new 3D information. And here's where we say what we want to see. So, for example, I don't have any joints, so I have to do linear displacement, meaning where the balls are in space, and I'll do segment. I'll do length. That would tell us how far separated they are. So I'll do length, displacement of point number 1 and point number 2, and we'll do it 3D. That's fine. Select. Okay. And now I go up here to graph and I say graph data, and I can do a single graph on each picture, or if I take that off, it would be multiple. Let's see, we want to do raw only. If I did raw plus
Linear envelope.
it's confusing if you don't know what it is, so don't do it.
It's the smooth function.
Go like that. So there's my data. And I'll put it down here. And I'll put this on the bottom. Now we have 3 things up. And we can go like that. And everything is synchronized together. Stop. I'll stop it there. So that's exactly what the distance is at this point. It tells me right here, if I watch, we're going on.
How many distance changing?
Yep. You can also actually put a graph up as well, or a table rather. I'm sorry. So wherever I stop it, it'll tell me exactly.
This is going to be fantastic. We have patients who have weakness in a leg,
And all you did is 2D.
Yeah, but I'm going to be able to isolate what exactly is weak.
Exactly.
Is it their buttock that's weak? Is it their hip that's weak? You know,
Absolutely.
and just with this alone, I'll be able to do it.
Absolutely.
Wow.
Yeah. Okay, so that's cool. And
What had to be guesswork before,
Yeah.
you have it numerically.
now let's do a different graph. We'll go back.
Also, if the guy want to fake it, and you got 3-4 samples,
Yeah.
the variation will be unbelievable.
Yeah.
So then you know he fake it. So you don't tell him he fake it, but
Exaggerate.
Bob had, well, it's a symptom
System
magnification.
Let's go back and do another graph. Let's see, we're here.
You see, for athletic also, what the implication is unbelievable, because there's no way the coach with superb athlete can tell where it went wrong. You look and say, well, you didn't use your arm, you didn't use your leg, but they're all guessing.
Right.
Here you know it right away.
So I'll go back, do another graph.
So quick question. Once you have that page the way you want it,
Yeah, you can save it as a display, and then you can bring up that display later on.
okay, and you can also save the actual video portion of that.
Absolutely.
To a disk.
Yeah. Oh, sure. Okay, this time I want to do, I could do segment angle, but in this case we'll say linear velocity of point number 1 in 3D. And then also linear velocity of point number 2 in 3D. So we'll see if my hands were moving equally fast, right?
Okay.
And it'll be confusing if I
But you have 3D, it's only one camera though.
Yeah, but it's okay. I mean,
Right, okay.
it's not going to be a different result. But let's say I actually had a 3D and I want to see the velocity along this line or specifically, then you could designate it.
Okay.
In this case, I'm going to take out the displacement that I just did because it'll make it confusing because it's apples and oranges. And I'll say graph. And I'll get rid of this.
Why would the taking out the displacement make it confusing?
Because now I'm looking at the scale is different. Inches per second versus inches.
Okay.
In fact, I'll put it back in and I'll show you. One of them is not going to be right. That's what the bottom line is. So I'll put it back in, and I'll graph it. So it chose to use the inches because that's the first one. So
right.
This is obviously not inches. This is inches per second.
Okay.
You're mixing the
variables.
The units. But sometimes it's important. Sometimes if you don't care for the number, but you want to know at what position it was the fastest velocity, then you're mixing up
okay.
That's fine.
But I would choose the one I want to be real first. Like if I'm interested in velocity, that would be the first one I would choose.
So you definitely do inches per second on that one, and the
right,
other one,
and then the other one will show you where it was.
Where the heel strike was.
Exactly.
So we'll go ahead and, well, we can actually leave this graph up as well. Put this one over here. I'm going to cover that one. And I'll say graph data. Bring it down here like that. And then everything again will play together.
Bob, go to the window on the top, just the window here after we finish. Window, where it's a window. You see it's a window here?
Window.
Yeah, and you see, and it's a tile. Okay, you got them all.
Okay. Now, one outstanding thing I see right away is that I was moving my point number 1, which was the left hand, faster than I was moving number 2. All right. So let's make this a little bigger, and we'll analyze it. And I want to know exactly how fast was I going at each of these points. So I could place the line right there, and I can see that at that point, the point number 2, which was the right, was moving at 4.29 inches per second, and at the peak right